Dear friends, engineers, consultants, and architects, in this particular fire safety series, I am going to tackle many different subjects related with the fire security. This will be detailed in next fourth presentation. Dear friends, before we discuss this entire series, it is very much necessary that you know what are the codes applicable in India for electrical distribution systems. The prime most of them is Indian Electricity Act as of 2003. Then National Electrical Code 2023 is also in vogue, but never read by either students or consultants properly. Next is, which is more important, is National Building Code of 2016 to be revised in 2025, but it never had happened in 2025. It may come in 2026. Next, India's primary electrical safety code is the National Electrical Code of NEC 2023, as already discussed. This is published by Bureau of Indian Standards. This comprehensive document sets guidelines for designing and installing safe electrical system in buildings and industrial structures, covering wiring, grounding, and special environments. The next is Central Electricity Authority. It has issued measures relating to safety and electrical supply regulations in 2023, better known as ECSBC 2024. In this, sustainability is also added. So this is known as Energy Conservation and Sustainable Building Code for Commercial and Office Building 2024 as issued by Bureau of Energy. Friends, this slide let you know standard voltage line to line for three-phase system as declared by National Building Code. The standard voltage single phase is 240 volts, whereas on three phase it is 415 volts. Then next one is 3.3 kV, then 6.6 kV, then 11 kV, then 22 kV, and then 33 kV. After that, 66 kV, 110 kV, 132 kV, 222 kV, 400 kV. These are the voltages which are from 110 to 400 and 750 kV are the transmission voltages in India, whereas 66, 33 and 22 to 11, these are the uh, so-called high voltage systems, standard voltage in India. Then we have three phase voltage as 400 standard. It should be this. Friends, this slide provides preferred range of distribution voltages depending upon different loads from 100 kVA up to 45 kVA, 45 MVA. Nowadays, electric supply companies are forcing the consumer to take ST supply at 11 kV if their maximum demand increases beyond 100 kVA, and it is beneficial to electric supply as suggested below. Up to 100 kVA, 415 volts, 3 phase. These are all 3 phase voltages. 100 kVA to 1 MVA, you may use 11 kV or 6.6 kV systems. Then 1 MVA to 2 MVA, 11 kV, 2 to 3 MVA, 22 kV. This is metro system, used in metro system, 22 kV. 3 MVA to 5 MVA, 33 kV substations of large premises. 5 to 10 MVA, 33 or 66 kV. Then 10 MVA to 20 MVA, 66 kV system, and 20 to 45 kVA, 132 kV. Friends, let us know the components of an electrical power system. A modern electrical power system consists of 6 main components: the power station or power generation station, a second, a set of transformers to raise the generated power to a high voltage used for used on transmission lines. Then high voltage, extra high voltage transmission lines. Then the substation at which the power is stepped down to voltage on the distribution line. Next is the distribution lines at high voltages. Next, the transformers that lower the distribution voltage to level used by the consumer's equipment. Friends, in case of local substation where ST supply at 11 kV has been taken, there are 6 distinct levels of electric distribution as detailed below. First one is, after metering, it goes to ST side of substation. It may be 11 kV or 6.6, where 6.6 very rarely used. That is ST panel and transformer. Then second, LT side, that is LT, actually it should be MV panel, MV side, which is rated 433 volts. Next is main distribution board or switchboard, MDV, main distribution board. The next is sub distribution board, SDV, and this SDV may be 4-way, 6-way, 10-way, and 12-way, and each way 4-way represents 12 circuits, 6-way represents 18 circuits. So go on multiplying number of ways, and as much kilowatt will be consumed by them. The next is circuit wiring, and next to that is point wiring. It is very much necessary to decide the location of the substation at the design stage itself. The substation should preferably located in separate building and which could be adjacent to the generator room. Location of substation in the basement floor should be avoided as far as possible. The ideal location for an electrical substation for a group of building would be at the electrical load center on the ground floor. The floor level of the substation of which switch room shall be above the highest flood level. Generally, the load center would be somewhat between the geometrical center and the air conditioning plant room, as the air conditioning plant room would normally be the largest chunk of load if the building is air conditioned, fully air conditioned. This table describes the requirement of outdoor yard of a particular 33 or 20 kV substation and built-in area housing 11 kV outgoing, oil circuit breaker, oil switch fuse unit, etc. So this table has been prepared by CPW depending upon capacity of the system in MVA and preferred voltage. This provides outside area of the substation and this provides the inside area of the substation. Friends, this slide shows a MV panel, previously called LT panel as per British code. This panel has got a number of cable allays. One here, 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 here. These are provided for taking the cables out from the switches, different type of switch, which may be MCCV, maybe a circuit breaker, or MCB itself. The panel has got two incoming air circuit breakers and one bus section which gets connected through this. These two are one for normal supply, one for generator supply. Any one of these will get the power and the power bus is connected here. It will have a three phase, one neutral and one earth, all duly insulated bus bar from here to here, so that it is easy to take connection to these MCCVs or MCVs. The MV panel may have several sections, both on the leftmost and rightmost sections may be provided for cable outlets and inlets known as cable alley. In most of the cases, only one cable alley may be provided, but this panel has got several cable allays. The medium voltage bus bars are provided at the top horizontal section. This is automatic transfer switch panel, automatic ATS panel. The ATS panel is provided in case of 11 or 33 kV system to switch over from transformer supply to generator supply. This is high voltage sort of automatic mains failure AMF panel. The slide shows a figure of outdoor distribution panels which are provided external to main building for feeding outdoor electricity to street lighting, outdoor campus loads for pumps, bollard, facial lighting, flood lighting, etc. They have essentially danger notice board and earthing lugs. This danger board and earthing lugs provided on this side here, this side and that side. So they have essentially danger notice board and earthing lugs for body earthing and lifting lugs and locking arrangements. The lifting lugs and this is locking arrangement. Friends, the figure on left hand side of this slide shows horizontal distribution as well as vertical. This is horizontal distribution through overhead bus bars as they are called. These are overhead bus bars. They are all horizontal but provided at a height. And this also shows vertical bus bar system known as rising bands. And these are the floor switchboards. Electricity distribution via horizontal overhead bus bars and vertical rising bands. The sketch shows how the horizontal overhead bus bar or ducting takes the electricity from MB panel and supplies electricity to different type of load. It also shows how the electricity is distributed over several floors above ground, floor to various basement level or to basement level, although not shown here. In this uh, uh, isometric view of horizontal distribution of electricity through overhead bus bars from the main panels, number of panels. So this shows the panel and horizontal distribution bus bar system, which is known as bus bar, overhead bus bar system. This is the main bus bar system from where mm, branch lines are also fed like this: one, two, three, four, five, six. The right left hand side of this slide shows the rising man distribution system, which is vertical distribution from man panel. There are three rising mans here. Electricity is taken to different floors above ground floor to various floors above and below via several rising mans in large buildings. One rising man is provided for approximately every 1,000 square meter of floor area. This particular diagram shows three vertical rising mans in approximately 3,000 square meter area. Friends, the figure on left hand side shows the real life rising man systems, vertical rising mans, one, two, three. This real life vertical rising man system is provided for three different purposes. The first one may be normal, feeding the normal load only through the transformer. The second one may be feeding the essential load which comes through generators. And third one may be the load fed through UPS. So this rising man is connected to UPS and distributes the power to different items which are on UPS, mostly computer equipment, computerized digital items. Uh, the, the three vertical rising mans are provided in one section of building per 1,000 square meter of floor area. One for normal load and second for essential load and third for UPS. UPS load can be supplied only for a limited period of 10 to 30 minutes. 10 to 30 minutes. Uh, that means in case of hospital, certain loads are connected up to 30 minutes because those are life-saving equipment connected to them. The UPS load after 10 or 30 minutes goes to generator if normal supply is not available from transformer, and all load which is on generator is finally transferred to uh, transformer normal rising man, which takes the entire load. Friends, I am introducing with you a new idea provided in National Energy Conservation Building Code. As you know, the ECBC 19 had been made popular for energy conservation point of view, and it provides parameters of several parameters in which of which one parameter is known as lighting power density, which is in power per square meter, and this is provided in ECBC buildings. And ECBC building, any building which is having 1,000 square meter of air conditioned area or having a load requirement of 125 kilowatt is called ECBC building. And in all ECBC building, the different part of the building should not have lighting power density more than prescribed in the second column, second and fourth column. Now you can look on in for office buildings, it is 10.8. So the sum of total office requirement must not be more than this lighting power density multiplied by the square meter area of that particular building. The ECVC code provides another concept also. Here the lighting power density should not be more than whatever provided, but here it is space function of a particular section of a building, say lobby for hotels, for office certain portion, then hotels, then other type of building. So this space function gives you power requirement for lighting, for reading area, in case of hospital, emergency, recovery, nursing station, exam, this one, so on. So you can choose uh, any of the two methods, space function method or building load function method. Friends, this sketch or drawing provides further distribution detail based on rising man. Say if this is a essential rising man, it is coming through some TPN switchboard of LT panel normal type. This is normal type. So this has got a 200 ampere connection box. From this, the connection is taken vertically in the rising man, and each floor has got a main switch. And from this main switch, there is a distribution board. The distribution board itself has got its incoming main switch, and then further MCVs or MCCVs. These are individual MCVs. In this one particular case, this MCV is feeding a load through cable on the same floor, which may be of 8-way, 4-way TPN distribution board. So these are the switchboard portion. This is the distribution portion. And this. Friends, this is a detailed drawing of main and submain distribution systems. I will tell you, this is income tax office building having two different sections, one outer section connected through corridors like this, and it has got a inner core section also. In both sections, they have provided vertical rising main system. Here, one on here, one on right hand side. This is getting connection and distributing further to various TPNDV systems here. So the man rising man is here, from it is going to various TPN distribution board of various types, maybe for normal, maybe for essential load, or maybe for UPS load. Thanks for me listening peacefully.